So this is the second part of a two-part lecture video on the urinary system. And in this lecture video, I'm going to be concentrating on urine formation. Main keys. So three main processes: filtration, which only occurs in the glomerulus; reabsorption and secretion, which actually occurs throughout the renal tubular system. And the renal tubules, if you remember from the previous lecture, consist of the proximal convoluted tubule, which I will now address as PCT, the nephron loop, also called the loop of Henle, and the distal convoluted tubule called the DCT, and the collecting duct as well. Okay, so reabsorption means that substances go from the tubular system, and the tubular system again is this, okay, is this tan or cream colored, into the capillaries, whether they're in the peritubular capillaries or the vasa recta. And note that the peritubular capillaries surround the PCT, the DCT, and the collecting duct, whereas the vasa recta actually surround the nephron loop. And then secretion is the other way. That's when substances actually exit the blood through those two systems of capillaries into any portion of the renal tubule system. Okay, and I should make a note that the most important thing, the reason why we actually need urine is one of the byproducts of protein metabolism is, if you've ever seen the structure of the amino acids, which was presented in the very first lecture, is ammonia. So the main thing that we're trying to get rid of in all of this is actually this substance called ammonia. And again, this is a byproduct of protein metabolism. So when we degrade proteins, when we break down proteins, when we digest proteins, this is actually a very toxic compound. I don't know if you've ever smelled ammonia. Ammonia actually stinks to high heavens. It's actually highly toxic as well. Okay, so that's actually the primary things that we're trying to get rid of when we make urine, Okay, so glomerular filtration happens in the glomerulus, obviously, and a very important deal here is all of the form elements of your blood, from the platelets, which is the smallest portion, all the way to your monocytes, which are the biggest component of your, in this case, of your form elements. Form elements mean cell components of the blood. They do not exit the glomerulus. Okay. And then even though it says small proteins exit the glomerulus, these small proteins are so small, so negligible, that we can actually say with like some form of confidence that there's actually almost 0% protein also in the filtrate that actually exits the glomerulus. Okay, but what is in the filtrate? Again, this is going, if I'm gonna go back, this is actually going to the space right now. Okay, that's what the filtrate is. This is actually the beginnings of urine. Majority is water. You actually have some nutrients, glucose, amino acids, a lot of ions, sodium, potassium, obviously chloride ions, bicarbonate ions, hydrogen ions, some hormones, some vitamins, ketones. We don't care about ketones in this class. And again, this should be 0% protein. Okay. Now, the how much is actually goes into the filtrate depends on how much blood is actually making it through the glomerulus. So the bigger the afferent arteriole, the more blood actually goes through the nephron, which means the more filtrate is actually created, and vice versa. Okay, so what happens next? So obviously things that exited into the capsular capsule, into the capsular space, actually then makes it into the proximal convoluted tubule. And a lot of those things that actually exit into the proximal convoluted tubule from the filtrate, from the filtration process, actually gets reabsorbed back into the peritubular capillaries, as you can see here. Right? So 100% nutrients. So that means to say that if you have 1,000 molecules of glucose exit here, all 1,000 of them eventually exits this tubular system into the peritubular capillaries. Okay, majority of ions. So the majority of ions that you actually secrete, like in this case that you actually filtrate out, so sodium ions, potassium ions, actually go back into the blood, all right, through the peritubular capillaries again. One of the things is phosphate ions. So even though it says majority of ions, phosphate ions may or may not be, it depends upon PTH. So if you secrete parathyroid hormone, which is about calcium balance here, okay, what happens is you actually then prevent phosphate from entering the blood. You actually make phosphate go all the way into the urine in this case. And then on the other hand, going from the peritubular capillaries into this area is some drugs, obviously, and nitrogenous waste. And again, nitrogenous waste, we're talking about any byproducts of ammonia. Very, very important. So then obviously that filtrate now enters the nephron loop. Very, very interesting thing here. The nephron loop, I'm going to tell you right now, is very weird. Okay, and the reason why it's very weird is in the descending portion of the nephron loop, it's actually permeable to water. So water actually gets reabsorbed in this portion. Okay, but in the ascending limb of the loop of Henle, it's actually impermeable to water. So water can actually not exit in this ascending portion. Okay, so quite interesting in this case, right? But again, and this is where you start controlling the secretion of water. So if you need more water, guess what? More water gets reabsorbed. If you don't need water, we're talking again about blood pressure and blood volume here. If you have too much water, what happens is obviously the secretion actually in this case actually goes this way. So but most of the time, ladies and gentlemen, in this portion, a lot of this is actually reabsorption of water, okay, and also reabsorption of ions in this case. All right, a lot of things, FYI, actually do not enter in this case. There's actually not a lot of there's actually zero secretion, if you want to think about it, that actually occurs in the loop of Henle with some minor modifications. Now, there's something quite important here. So there's this hormone called antidiuretic hormone. Okay. Now, why is it that only water gets reabsorbed in the ascending into the descending limb, and why does water not does not exit into the descending limb, into the ascending limb? I'm sorry, going up. And the reason why that is there's actually a system called the countercurrent mechanism, and so water cannot exit in this portion, but ions do. So sodium, potassium, okay, and 2 chloride ions, symporters, actually get reabsorbed. And so what happens is, if you want to think about it this way, you actually have the vasa recta, okay, this is the vasa recta, which is the capillary system that surrounds the nephron loop. It's going to be very, very high in sodium, potassium, and chloride ions, right? I hope that that makes sense. And because of this, that is actually one of the big drivers of water, because water obviously follows solute. Remember, hypertonic, hypotonic, isotonic. So if you make a hypertonic solution by having a lot of solute, sodium, potassium, and chloride ions in the blood, water follows because of osmotic pressure. If you do not, in this case, reabsorb too much sodium, potassium, and chloride, then not a lot of water actually follows. So again, so this is another way for you to control, in this case, water reabsorption. All right. And again, a very, very major agent for this one is ADH. And then here we go. This is where everything gets confusing. So the distal convoluted tubule as well as the collecting duct is the most complex portion of the nephron, because this is where a lot of things can go one way or the other. So here we go. Sodium reabsorption is regulated by aldosterone and ANP. Aldosterone, okay, increases sodium reabsorption. ANP, on the other hand, which is atrial natriuretic peptide, actually decreases sodium reabsorption. Why is that? So aldosterone is part of the RAA system, the renin-angiotensin, okay, aldosterone system, and this is actually secreted when you have low blood pressure. So when you have low blood pressure, the big thing about your urinary system is it wants to keep water. So if you reabsorb sodium, one of the weird things about sodium is wherever sodium goes, guess who follows? Water. So the more, again, just like the countercurrent mechanism that I mentioned previously, so the more sodium you take back, you reabsorb back into the peritubular capillaries, the more water you actually reabsorb. Okay, so that's in low blood pressure. So aldosterone, low blood pressure, you get more sodium back into the blood through reabsorption, which means you get more water following sodium. When you have too much water volume, which means you have drank too much water, that means you have high blood pressure. And the reason why it's called ANP is it's actually created in the atria. Your atria then gets too much volume going back, which means there's going to be a big stretch of the atria. So if the atria senses that there's too much water going back, it actually releases this hormone called atrial natriuretic peptide. And in response then, it decreases sodium reabsorption. Why? Because if you don't reabsorb sodium, water does not get reabsorbed, and then water then gets excreted, and obviously that decreases blood volume, which hopefully will decrease your blood pressure. Okay, so that's the main thing about sodium reabsorption in this portion here. Another important thing, however, is if you look at this is, again, so we've kind of talked already about this, right? Now, what we haven't talked about is ADH. So ADH, atrial, in this case antidiuretic hormone, actually takes effect in the collecting duct, primarily speaking. And before, aldosterone makes you reabsorb water indirectly. How? By sodium reabsorption. Now, however, ADH on the other hand directly, actively makes you pump water in, and it's actually through a protein called aquaporins. Okay, and aquaporins are actually membrane channels that are permeable to water. So if you need more water going this way, what happens is more aquaporins are expressed on the cells, which means more water actually goes back into your peritubular capillaries. If you don't want water, no aquaporins, not a lot of aquaporins, which means you excrete water in this case. Okay, so the very, very important thing here is if you look at this one, it says amount of potassium is blah, 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 blah. If you reabsorb sodium, okay, very, very important factor here. If you take in sodium, which means you're going to bring in water, guess who moves the opposite way? You have to replace it with potassium. Okay, so that's a very, very important factor here as well. All right, so and that's through intercalated cell and principal cells. We already talked about calcium reabsorption before. Again, this is by PTH. So obviously, if you have PTH from the parathyroid gland, what happens is more calcium ions go back into the blood. Okay. Now, a very, very important thing here. So, type A cells or type B cells. Type A cells are more active if your arterial pH is below 7.35. That means you're acidic. So if you're acidic, your type A cells gets rid of hydrogen, okay, into the urine. And on the other hand, this is blood, peritubular capillaries, by the way. And then the same token, it actually, in this case, reabsorbs bicarbonate ion. Now, why do you want to reabsorb bicarbonate ion and get rid of hydrogen ions? If you reabsorb bicarbonate ions can actually neutralize excess hydrogen ions, which is a result of your pH lower than 7.35. Now, obviously, if your pH is above 7.45, which is the upper limit of arterial pH, it's the opposite. Type B cells then, in this case, so this whole movement here gets reversed. So then bicarbonate ion exits into the urine, and more hydrogen ions actually get reabsorbed back into the blood. All right. So the nephron, the urine formation is very, very complex once we get to the distal convoluted tubule and the collecting duct. And so the peritubular capillaries in this area is a little bit much more complex. In the nephron loop, just remember that one of the big drivers of that water reabsorption is by how much sodium, potassium, and chloride ions actually exit. Okay, so the more of those ions actually exit, the more water actually exits. Okay, and that is actually, but the only portion that you actually truly control in terms of water balance is actually this portion. So please make sure that you focus on these processes involved in the distal convoluted tubule and the collecting duct.